concept of limits stays with us throughout our journey of calculus. I want to go over a couple that you may have seen. Let's start with the limit of sine x over x as x goes to 0. So this one is difficult. Like if you plug in numbers, depending on what you plug in, you might start to get wildly different answers. It's not totally obvious. Another thing that's a little tricky about it is, for those of us who do calculus, later a technique is taught that allows the computation of this limit to be very easy. And I actually do want to show you that technique, even though it's something that you'll hear about later. Now, this technique is called L'Hopital's rule, and what it states is that if you have a limit whose numerator is 0, sine 0, 0, and whose denominator is also 0, x goes to 0 would just go to 0. So you get 0 over 0 here. Or infinity over infinity, that also applies. You could take the derivative of the numerator and the derivative of the denominator separately, and you still arrive at the same limit. Okay? Now, how in the heck does that work? Well, let me show you. Basically, it's saying, by L'Hopital's rule, you can say that this is equivalent to limit as x approaches 0 of, and then you can get the derivative of sine x is cosine of x, derivative of x is 1, but now you can plug in the 0, and you get 1 over 1, and because this equals 1, the limit as x approaches 0 of sine x over x also equals 1. Okay, that's how I do it. There are different techniques that you can use to get it, like a squeeze theorem, geometric argument, but I don't know, this is the one that stays with me. So you can see similar ones like the following. You could have the limit as x approaches 0 of what? You might get something like this, sine of 5x over, say, 2. Now, 2x. Yeah. Now this is not the same as sine x over x, right? Sine is 5x over 2x. But if it was over sine 5x over 5x, then it would apply. So all you do is you can multiply through by 1. And for a multiplication by 1, we want to use, let's say, keep it simple, 5 over 5, right? And now we can do a switch, and we can pull out we can basically swap the 2 and the 5. So we get 5 halves times sine 5x over 5x, and now it's clear you can pull out the 5 halves, and the limit as x approaches 0 here, that is going to be equal to 5 halves times 1, because we know that the limit is x goes to 0 if sine x over x is 1, and so we get 5 halves here. Okay, that's kind of cool. So let me now get to another limit that you may have seen, and I want to start with the derivative of e to the x. So we've said that the derivative of e to the x is e to the x, right? That's that operator notation. Take the derivative of what's in the parentheses and it's e to the x. Now, what if we look at this in context of our original definition of the limit? So this is the limit as h goes to 0 of what? Well, we're going to apply, don't run any of the parentheses there. It's let's just write it out. It's f of x plus h minus f of x all over h. And here, our function is going to be e to the x. So this is limit as h goes to 0 of e to the x plus h minus e to the x all over h. Now you can rewrite this as follows. Limit as h goes to 0 of e to the x e to the h minus e to the x over h. And clearly you can pull out an e to the x, right? So we get the limit as h goes to 0 e to the x, and then we're left with what? E to the h minus 1 over h. So the only way that this limit can equal e to the x, which we needed to do because this is the definition of the derivative, and we've given this definition that d dx e to the x is e to the x, is for e to the h, basically, okay, when h goes to 0, okay, e to the x is not affected, right? There's no h in there. So you can pull that out, and what we're left with then is that the limit as h goes to 0 of e to the h minus 1 over h equals 1. So this is given as an alternative definition of e to the x. And you can start from there and arrive at, therefore, the derivative of e to the x must be e to the x. So I just want to highlight this limit because it's not, like if you just look at it, it's not something that easily, like you can get to be 1, okay? Whenever you have e involved with limits, look carefully, and this is one that maybe you could remember if it comes up again, okay? So those are a couple of interesting limits involving trig and involving e to the x.